Hi everybody and welcome to the final video of the Generating Melodies with LSTM Networks series. Last time we built the Melody Generator class, which is a wrapper around the Keras model that we trained, and that has this generate melody method that's the kind of like core of what we wanted to build, because it generates a melody using our deep learning model, and then it kind of like stores it in the time series music representation. Now, the final thing that we want to do today is to take that melody and then convert it and save it into a MIDI file. Okay, so for that, we're going to create a new method in the Melody Generator class, and we can call this method, I don't know, something like save melody. Okay, and so here this method, it's going to accept a number of parameters, arguments. So the first one is going to be the melody itself, obviously, and so this melody is going to be in a list, and we're going to have like all the symbols as the items of this list, which are those that we've used for encoding series, a melody. Okay, so then after that we need to specify a format, and we'll default this to MIDI. So this is just the music format, music representation file that we want to use. And as I said, we'll default this to MIDI, but it could easily have been something like music XML or Kern, for example. And we also want another optional argument that we call file name, and this is just the name of the file where we'll store the melody. So yeah, let's put this mel.midi. Finally, we want another argument, and we can call this the step duration. So this step duration is just the amount of duration in a quarter note length that we have at each step in our time series music representation. And as you should all be familiar by now, in our case, this is equal to 0.25, which is equal to a 16th note. Okay, so now we should implement an algorithm that takes the melody list and converts it into a MIDI. So there are a bunch of things that we should do here, but let's focus on the highest level first and just outline the different steps here. First thing we want to do here is to create a music 21 stream. So what's a Music 21 stream? So if you followed along during the series, you should be familiar with that. But Music 21, first of all, is a music library that we can use for notating complex scores in an object-oriented way. And a stream is just an object that acts as a container, and we can push into a stream all the notes, rests, and all the other information that we need about a score. Okay. But for creating a Music 21 stream, obviously we need Music 21, this package. And so I'll add it here. We'll do import Music 21 as M21. Okay, so this is the first step. Then the next step is to pass all the symbols in the melody and create note rest objects. So we'll go through all the elements in the melody list, and then we'll just create notes and rest objects. And these are Music 21 objects. And once we have that, we can just like push them into the Music 21 stream. And finally, the last bit we need to do is just to write the M21 stream to MIDI file. Okay, so let's start from creating a Music 21 stream. So here, this is extremely straightforward because we can call m21.stream and then we instantiate a stream object. So it's as simple as that, really. So now, one thing that I want to specify here is that in a stream, you can have a bunch of subcontainers and sub-subcontainers. So the most important ones that I've already discussed in a previous video are parts and measures. So given we only have like a monophonic line, we should have like a single part. So I'm not going to create a part object and push it into a stream. Same thing for measures. So I'm not going to create measures and put them into the stream, nor am I gonna put in time signatures. I'm just gonna use like the defaults that Music21 comes out with, which is a simple 4/4 bar in C major, which is, by the way, like the kind of key that we're gonna be using anyways. So yeah, if you may be wondering why I'm doing that, it's just because I want to do to keep this as simple as possible. So if you want to create a more elaborate version of the MIDI file, so you are free just like to play around with Music21 and have that happen. Good. Okay, so now the next step is the real key. So we want to go through all the elements of a melody list one by one, and then just like convert them into the relative notes or rests. But in order to understand how these algorithms is going to work, let's take a look at an example of a melody. So let's assume we have something like this, right? So we have a C note, middle C note that's held for a quarter duration, so it's a quarter note. And then we have, say, a rest here, and then we have this D note over here. Okay, so now I haven't put in that into a list, but obviously like each of these symbols is going to be an element in the melody list. So now, so what's the reasoning behind the way we want to convert this list into an actual Music21 objects? Okay, so basically the intuition here is that, so we are going to go through all of these items one by one, all of these symbols, and then whenever we hit an event, let's call it this way, and an event could be both a MIDI note or the R symbol, which stands for rest, as you should know by now. So whenever we hit that, so we keep track of that information and we just continue, because there may well be prolongations to that initial note. So in this case, we hit 60, we keep track of 60, which is this middle C note, and then we go ahead and see that there's a prolongation. So we continue, there's another prolongation, we continue, there's a third prolongation. And then when we hit a new event, we just say, okay, so the previous note, the duration for the previous note is basically done. Okay, so now that I have the information both about the MIDI notes, the pitch, which is 60 in this case, and the duration, which is 4 time steps, I can reconstruct the Music21 object, passing in information about duration as well as pitch. Right, so and then we move on. So now we have R, and R is the new event we keep track of, and then we move on. So the next is a prolongation, so we can continue until we hit 62. And so now we do the same thing. We know that given we've hit a new event, this MIDI note, so the previous note, in this case a rest, is done, and so we should infer both the symbol itself, which in this case is a rest, and the duration, which is in this case a half note, so 0.5 in quarter left duration. Okay, so this is the kind of high level idea of how we're going to pass all of this information. So now let's implement this. So as a first thing, we need to initiate initialize a couple of variables that we'll need. So we'll call this start symbol, and we'll initialize this to none. So the start symbol is it should be like an event, or either a MIDI note or a rest. I'll show you why we need this in a second. Then the other variable that we want to initialize here is the step, let's call it step counter, and we'll initialize this to 1. The step counter is going to keep track of all the steps that we have for an event, for a start symbol. Okay, so if we have a step counter equal to 2, then it means that we have 2 steps, which is basically a half note. If it's equal to 4, then sorry, it's not a half note, it's a eighth note. I usually, I don't know, confuse eighth notes and half notes. I don't know why. Okay, but let's go back here. So I was just saying that if we have a step counter with 4, then that means that we have a note that has a quarter note. Well, it's a quarter note, right? Okay, so now the next step is the crucial one, which is that of going through all the items, all the symbols in the melody list. So we'll do a for symbol in melody, and here we should handle a couple of cases. Handle case in which we have a note rest. Handle case in which we have a prolongation sign, which is this underscore sign over here. Okay, so let's let's create this conditional statement. So we'll do if the symbol is not equal to underscore, then we'll do some stuff. Instead, in all other cases, it means that the symbol is going to be equal to the underscore sign, which is the prolongation. And so if we are currently in a symbol that's a prolongation symbol, what we want to do is to just increase the step counter by 1. And the reason why is that because, say we started here, now we move to the next symbol. At this symbol, this is a prolongation symbol, so we want to add to this initial step counter equal to 1 another unit so that it is equal to 2. Right, so that we can keep track of the duration of the note there. So we'll do a step counter plus equal 1. So we'll just increase the step counter by 1. Okay, so this looks good. So another thing that we need to do here is to, when we are dealing with notes or rests, so we want to differentiate between when we are dealing with notes and when we are dealing with rests, okay? But even before that, we want to be sure, so ensure we are dealing with the symbol, let's say with note rest beyond the first one. Yeah, I really don't like this comment, but I mean, the point of this comment is that I want to be sure that we are not dealing with the first event, the first either note or rest, but we are dealing with this a second event here. So how can I be sure of that? Well, we should say that if start symbol is not none, then we do some stuff. Now, I'll explain why this is important, and you'll see that in 5 minutes or so. But so let's assume that we are not dealing with the initial symbol, right? So not with this 60 for in our example, right? Sorry, but I've noticed that I have a typo here. So start symbol, same thing here. Okay. Okay. So now let's continue by creating, by handling two different cases. So case number one is we want to handle a rest. Case number two, we want to handle a note. So it's the difference between having a MIDI note like this or an R symbol like this that stands for rest. Okay, but even before that, what we want to do is we want to calculate the duration. Let's call it quarter length duration. Okay, so how can we calculate the quarter length duration of the start symbol? Now, what this means is that if we are here, right? So we know that the start symbol is going to be this 60 over here, and we want to calculate the duration in quarter length. And so for doing that, we need to multiply the step duration, which is the unit of time expressed in quarter length duration, which is 0.25 in our case, multiply that by the step counter. So now let's just try to make an example with our example, with this example here. Okay, so here the step duration is 0.25, and then we multiply that by 4, which is these steps over here before we hit the new event, which is R. And here this is going to be equal to 1, which is a quarter note, which is great. Cool. Okay, so now that we know the quarter length duration, as I said, we should differentiate between whether we are handling a rest symbol or a note symbol. Okay, so here we could say that if start symbol is equal to R, so we are handling a rest, and in this case, we want to create an M21 event, and this event is going to be a rest object. So we'll do a M21 dot notes dot rest, and here we can pass in the quarter length optional argument, and obviously we'll set that to our quarter length duration. Okay, so a rest object, obviously in Music 21 is an object that indicates, that represents a rest, and obviously it doesn't have any pitch, it just has duration. Okay, so now let's handle the case in which we are dealing with a note. So the start symbol is a MIDI note. In our example, we would be dealing with this 60 value over here, which is middle C. Okay, so in this case, the M21 event is going to be equal to M21 dot note. And here we need to pass, first of all, the actual pitch, the MIDI note. And so for that, we'll take an int here, and then we'll use this start symbol. So if we are down in here, we know that this start symbol is going to be a string for sure, but a number expressed, an integer expressed as a string, because it's a MIDI note. And so we want to cast that to int. Okay, and then obviously we'll still need to pass the quarter length duration. Okay, so this should work. Okay, so now that we are done here, we have our M21 event, so we can just push that event into the stream. Actually, we should append it to the M21 stream. So we'll do a stream.append, and we'll pass in the M21 event. Now, another key thing that we need to do here is to reset the step counter. So we should take the step counter and put it back to 1. So why are we doing that? Well, because now that we are here in R, right? So what we've done is processing like this previous note where the step counter was equal to 4 because it had 4 steps in it. Now we want to start counting again to keep track of this R note over here, right? And so we need to start from 1, and then at the next step we'll add 2, and then we get, when we get over here, we'll just reset the step counter once again. Okay, and finally the last bit that we want to do here is to update the start symbol. Okay, so the start symbol now is going to be equal to the current symbol. Okay, so I know like the flow like in this code may feel like a little bit weird, but now we can go through it once again and just like understand what it does precisely. Okay, so let's assume we go through like all of this code, all of this. Oh damn. We go through all of these melody items here. So, and let's see what happens. Okay, so we go the first time into this loop. The first symbol is this 60 here, which obviously is a note, right? And so we're going to get into this instruction here, so into this conditional. But then we're going to hit this. So if start symbol is not none, then we are going to have access to this. Otherwise, we won't have access to that, right? Okay, so what that happens though is that the start symbol should be set to the symbol itself. So, and here I've noticed a mistake, an error. So this start symbol should be here because obviously we want to update the start symbol with the current symbol, even though the start symbol is none. And that's because, so if we had this, as I had it before, what would happen is that we would never enter this condition here because we would never change start symbol with the current symbol. Okay. Good. Okay, so now we know that this start symbol is 60, and now we just go back and we continue the for loop over here. And so now we hit 3 prolongation symbols, and at every time we just loop through this conditional else statement here, and we increase the step counter until we hit this R symbol over here, which we know is the symbol for rest. So we get into this statement, into this statements here. And now for the first time, we enter this conditional here. That's because the start symbol is not known because the start symbol is equal to 60 as we set it before, right? And so now we just look back at the start symbol, we extrapolate its quarter length duration, and then we create an M21 event. It could be either a rest or a note. In our case, we have 60, so it's going to be a note object, and then we append it over here, and now it's time to reset the step counter. Good. So we continue like this until we reach the end over here, right? But guys, we have a problem here, right? Because we've reached the end, but we don't have any additional event, like, I don't know, like a note or a rest symbol. And so we can't really log this last note, right? Because we log that only if we hit a new note, okay? But there's no new note here, right? because we're at the end of this. So how do we fix this? Well, we can just say that we'll enter this conditional in two instances. One of these instances is obviously if we have a note or a rest, or if we are at the end of this melody, right? So if we are at the looping through the last item of the melody list. Okay, so how do we do that? Well, that's very simple. So we'll do a enumerate, and we'll take the melody over here. So here we have the counter for this loop, and so here we'll just add an OR statement, and we'll say, so we'll enter this instructions here if in case we have a note, a rest, or we are at the end of the melody list. And so for that, we can say that I plus 1 is equal to the length of melody. Good. Okay, so now this should work. Hopefully I haven't made any mistakes, and so this whole algorithm should work. Now the final thing that we need to implement here is just writing to a MIDI file. But this is like very straightforward because we get this stream object, and it has a method that comes obviously with a music21, which is called write. And here we should pass the format and the file name, and magically music21 is gonna convert its objects into a MIDI file. Okay, so now let's see if this works. And so here we have a little bit of a script. Now I've added a couple of seeds here that will pass into the generate melody function here for generating a melody. But now the final thing that we want to do here is to take this MG object, so the melody generator, and then we want to save the melody, right? And so we'll pass in the melody over here. And I think like we don't need to pass any other arguments because they've all been defaulted here. So yeah, they're all optional. Okay, so now let me run this, and fingers crossed this should work. Okay, let's see. Okay, so we are loading TensorFlow here. Okay, here we go. So yeah, it seems like it's working fine. So over here we have this nice little melody that has been produced, and then I think we created a new file over here that's called mel.midi, and so we should be able to open this. Okay, so I had this file mel.mid, and this is like from a previous run, so I'm gonna like delete that, and this one I'm gonna rename, calling it mel.mid. Okay, so now it says it as a MIDI file, so I can open it with MuseCall. Okay, good. Okay, so here we have like our little melody, and I assume like these first notes are the seed that we've passed in, and so let's see like the rest of the melody here. Nice. Okay, so it's a very short melody, but the great thing about this is that, as you can see, the model has learned the idea, the concept of key here, because everything like is in C major, and it also recognized the idea of tonic and dominant. So it moves from this C, which is the tonic, to the dominant of the 5th degree of the scale, and it has a little bit of a sense of like rest towards the end of this initial phrase and the second phrase. By the way, it also learned how to create like phrases using like rests in the middle like here. So we have like these two nice little phrases. Okay, so now let me just change a few things here. So, and we'll rerun this. So first of all, I should fix this and call it mel.mid, not MIDI, because for quite a weird reason it doesn't read like MIDI as a MIDI file. But now, so here, if you guys remember from my previous video, so this is a parameter called temperature. So we can raise the temperature here to have the network being like more unpredictable. So let's rerun this with the same C2, which is this guy over here, and see like if we get like something else as a result. So it's worth saying that this is a non-deterministic algorithm, so we may get like something quite different from the previous time. Okay, so here we go. Okay, this thing over here seems to be like a quite long melody now. Okay, so let's select this. Oh, no, I don't want to open this with VLC. I want to open this with MuseScore. Okay. Okay, so let's take a look at this and see if it works. Okay, a nice little melody. So there are a few things that I find interesting here. So there's, I mean, musically, kinds of like sounds okay. I think like that there's some things that the network did really well. So for example, it basically reused the same ideas or like similar ideas over here. So if you look at this structure here, okay, it sounds very similar to this, right? So it more or less used a similar idea. Obviously it's a variation, but still like it kind of like reminds you like of the same musical idea, which is great because music is all about repetition and variation of like basic ideas. Then another thing that I thought like was really nice is this the closure, the sense of closure that we get when we get towards the end of this melody. Yeah, we just go back home to the tonic and there's a sense of rest. Now another thing that I think like the network like understood more or less is the idea of time signature, because it respects it like quite well. Okay, so now let's try a last to generate like a last melody and evaluate that. So I'm going to use this other seed down here, and I'm going to bring down the temperature to 0.3, so that it's going to be like less unpredictable. By the way, the previous melody was a little bit more unpredictable because, as we said, like we just raised the temperature, so it probably picked things that were like less with like smaller scores. Okay, so now let's rerun this and see what happens here. Okay, so I'm gonna open this once again with MuseScore, and let's see the result here. Okay. it's a nice melody. It's quite convincing, this one as well. So once again, it was the network was able to reproduce this descending motion over here that was in the seed. So G, F, E, D, C, and you have something like that down here, which is nice. Again, you have this idea of repetition and variation, which, by the way, you also have here. Okay, and here you just like end this first phrase, and then you start with this other phrase. And it's nice because it also has learned the concept of dominant and tonic, and the dominant that leads, or in our case, this G note that leads to C as a kind of like closure movement. Okay, so this is it. So like if you've followed along so far, you should congratulate yourself because you've built probably your first generative model using deep machine learning. And so yeah, I think like this was like a really interesting like series for me, like to shoot. I hope like you've had like a good time and you've learned a lot of new things, and it wasn't just about like learning how to build a generative model with an LSTM network, but also to I hope you've also learned how to manipulate data, symbolic music data, and how to represent music. And if you're not a musician and you don't have a background in that, I hope you've also like understood more or less like the basic ideas behind melodies and music theory. Okay, so that's all for today. So as always, like if you like this video, remember to leave a like, and if you haven't subscribed, please do so. If you have any questions or suggestions for future series that you want me to make, please leave them in the comment section below, and I'll see you next time. Cheers.